Good evening. My name is Shmuel Melamut. We will be talking about new feature in oVirt 4.1 that is called sparsify. I'm working on oVirt in Red Hat company. If you have some question during the session, you can ask them here in the chat near YouTube translation or on the oVirt RC channel. I'll answer them at the end. So, what is sparsify? I'll demonstrate it on an example. We'll enter oVirt engine administration portal. Here you can see list of VMs. I have this VM running. Let's look on it from within. I connect to its screen. So we see it's Fedora 23 virtual machine. It has one disk, uh, 8 GB in size, and only about 800 megabytes of it is really used for some data. If you look on our storage, it is located on an FS server. We will see this file that has size 8 gigabytes, but really it is not using the whole disk space. It is using slightly more than 900 megabytes. This file is sparse. That means that some parts of it are not really reside on the disk, because we don't use the whole disk for our operation. And if VM never wrote to some part of the disk, this part is not stored on the storage. We'll now create one large file to show how this size will be increased. We'll fill it with some random data. see that additional space was allocated for the disk. Now we'll remove this file. We don't need it. Yes. The occupied space on the file system is the same. We just created file and removed file. But allocated size of the disk is increased and will not be decreased because there is no such mechanism to remove the space that is not used by file system. In real life, when your VM is running for a long time, there will be files that are created, removed, updated. The space is allocated but never returned back to the storage. You can get the disk that is much larger that you really need, and it is eating storage that may be used by other VMs. That's why we created the new feature that is called Sparsify that is able to return the disk space back to the storage. First of all, let's power off the virtual machine. We cannot operate on the disk when VM is running. Nobody should write to the disk when we are using Sparsify. VM is down. We go to the disk subtab. We see here the new button Sparsify. The process is started. Disk is locked in the process. The Sparsify inspects the disk, its file system, finds what clusters are not used by the file system, by any of the files, and discards them. So this part of the file will be unallocated. It is finished. We can look on our disk. It is back 900 megabytes. We can run our virtual machine again to be sure that it's still working and nothing was broken. The same picture. So Sparsification lets us to save some space on the storage, use it more optimally. How it works. We have host in this cluster. I left only one host on the cluster, but Sparsify can run on any host. And that's why you must configure all hosts in the cluster in the same way. So Sparsify is installed on all hosts. There is utility that is part of libguestfs package that is called Virt-sparsify. Virt-sparsify is making the main work. It is analyzing the disk image and removes unused space from it. Because it is part of libguestfs package, libguestfs must be configured properly to work with libvirt on the host. We have special utility to check this. libguestfs test tool. I can run it and check that our setup is correct. Currently, it is returning error because libguestfs is configured to work from VDSM, so it must work from VDSM user. We'll run it on the VDSM user. You see, it is finished okay. So sparsify feature is running on the host side. VDSM runs Virt-sparsify utility on the disk image that you are planning to sparsify. Let's look on the code. We have new API call here, image sparsify, that is getting UID of the image of the storage domain. And we added the new SDM call that is called SDM sparsify volume, that gets volume information and job ID. I'll explain what it is later. Because it is SDM verb, it is running on any host. It doesn't require to be run on SPM. It is implementation here, specify volume, and here we are creating sparsify volume job and scheduling it. Sparsify is running asynchronously. It is running in separate thread inside VDSM. That's why we are using job mechanism here. Let's look on the job in the run method. We are calling sparsify in place. That is calling our command Virt-sparsify. We are calling it with in-place key, so we make all changes in place. We don't create a temporary image, don't take additional space on the storage. We don't copy anything, we are just removing parts of the file when they are not needed. On the engine side, we have the call in the JSON RPC and VDS command that invokes it, and sparsify image command that validates all prerequisites, the disk exists, that all VMs that are using the disk are down, and that sparsify is supported. And then it runs a sparsify image VDS command and using the callback to get information about success or failure or what is happening with the job on the VDSM side. It is inherited from storage job command, and the callback itself is inside the storage job command. We see it here. Why we're talking about prerequisites? Because there are many situations in which sparsify cannot work for some reason. We know that VM should be down, that disk should not be shared between several VMs. We also can take a look on some VMs here. And see that sometimes sparsify option is disabled because, for example, if you have pre-allocated disk and want to sparsify it, it doesn't make much sense. Pre-allocated option is used when you want to get maximum performance and you want to avoid fragmentation or disk allocation operations that may happen when your VM is running. That's why you are creating a disk, marking it as pre-allocated, and it gets the all space that it is possible to use. If you create disk 10 gigabytes, it gets the whole 10 gigabytes of physical space on the storage. Sparsify is something opposite. With Sparsify, you are returning to the storage the space that you are not using at this moment, and when you maybe will use it in the future, you will allocate it. It's not the same as the pre-allocation, so sparsifying pre-allocated disk doesn't make sense. Also, Virt-sparsify utility works with images that reside in file system. That's why block storage disks, cinder disks are not processed with Virt-sparsify. If you have several snapshots, it means that your clusters are partially may reside in one snapshot, partially in another snapshot. Virt-sparsify always works on the last snapshot, on the active snapshot. Why? Because at any moment you may return to some of the previous snapshots, and these snapshots should be untouched. If you created a file in your VM, then created a snapshot and removed this file, you cannot return its clusters back to the storage, because at any moment you may want to return to the previous snapshot where the file was existing, and the file should be in place and its clusters should be filled with data. So we cannot return to the storage space from the previous snapshots. If you really want to sparsify the disk with snapshots, you can merge all snapshots into the one and then run sparsify on it. Also, one moment is related to the network file system. Virt-sparsify works on disks on a file system that is mounted from some other host, and it may be mounted with different types of network file systems, and not all of these file systems support sparse files. For example, if you're using NFS, you must be using NFS version 4.2 as minimum. It should be set on the NFS server, and it should be set in the mount options. If you look at the NFS server here, we have version 4.2 here. Other types of network file systems may have other requirements. You may create a sparse disk image and try to sparsify it with Virt-sparsify utility. If it works with your network file system, that's okay. The sparsify may be enabled for it. If you have some questions, I'll be ready to answer them. Let's look on it. I'll wait a minute. If you want to ask something. You see here the sparse image of Fedora 22. Is using only 700 megabytes. If you don't have any questions, thank you. And we'll be finishing our session.